Hello and welcome to this online training course in which we'll continue to cover a few advanced notions on the use of CBA-32P and Cbawin. Produced by Zensol Automation in collaboration with Hydro-Quebec. Objectives of this module. By the end of this module, you'll be able to record and view any signal present in substations, with the exception of vibroacoustic and electromagnetic signals. What's behind an analog input? One or two analog input columns are available for a total of 3 or 6 analog inputs. These analog inputs give the CBA-32P all its power and adaptability to your needs. In fact, just a few key questions will enable you to record any physical event. What kind of signal am I trying to record? Is it a current, a voltage, a pressure, a displacement, a temperature? How long does my signal last? Is it slow, fast, or ultra-fast? Is it repetitive? What kind of sensor should I look for to record it? In fact, these analog inputs accept any type of sensor with an analog output from 0 to 10 VDC. Once you've found the right sensor, all you need to do is set the 2 key parameters of sampling time and total recording time. These analog inputs are mainly used for displacement testing. However, some electricians also use them for voltage, current, and pressure tests, as well as for dynamic contact resistance tests. How to activate an analog input on the green button 3? Simply click on the 3rd green button to activate or deactivate the inputs, which will then be displayed on the front panel. The number of the first analog channel is 1, which is the closing current. Number 2 is the opening current. Analog inputs 3 to 8 are the multifunction inputs available to the user. Knowing this number will help you visualize it. This number is shown on the front panel of the instrument or on displays such as this one. For example, the electrician has chosen to connect a linear displacement transducer for a KSO circuit breaker to the analog input. Look on the sensor for the calibration value entered by Zensol. These calibration values must be given to Cbawin for exact correspondence between electrical, mechanical, and binary values. We can see here that the 0 is associated with 0, while the 10V is associated with 614 mm. Finally, the operator has chosen the color green for the displacement signal. What's behind an optical encoder input? The optical encoder is a rotary motion sensor. The Omron encoder used by Zensol produces around 2,000 pulses per evolution. To simplify matters, all we have to do is count them, and we obtain the angular displacement at each instant with great precision. This information is combined with mechanical knowledge of the circuit breaker and the mechanical interface used. It is then more or less easy to mathematically deduce the distance and speed covered by the circuit breaker's moving contact. In fact, the CBA-32P incorporates 2 counters that help to capture the change in rotation as well. All these binary values are then stored in memory in 16-bit format. The advantage of such a sensor is that, unlike resistive analog sensors, it requires no prior positioning. How do I activate an optical gold code entry using green button 5? Simply click on the 5th green button to activate or deactivate the inputs displayed on the front panel. The number of the first channel in the optical gold code is 89. The last is 94. Knowing this number will help you visualize it. This number is shown on the front panel of the instrument, or on displays such as this one. It's easy to change the name, color, unit, and proportion of the selected signal using the property button. What's behind the control connector? Once the control cable has been connected to the circuit breaker cabinet, the CBA-32P takes full control of the circuit breaker's closing and opening operations. The cable is designed in such a way that it completes the control circuit for the closing and opening operation. It is made up of 4 conductors, 2 common, one for the closing coil and the other for the opening coil. Analog inputs 1 and 2 are paired with control outputs. The internal closing control circuit consists of a contactor in series with a Hall effect current sensor. This circuit is repeated twice, once for the open command and once for the close command. The contactor is needed to pick up the circuit breaker's closing or opening coil. This time, which must be very short to avoid burning the coil, is entirely configurable by CBA-Win. The current sensor is required to record the current signal. This signal is important because it is used to calculate closing and opening times. Without this current start information, we cannot calculate the operating times required for synchronization. How do I configure close and open commands using the V1 green button? The control circuit is important because it enables the circuit breaker to perform any operation. Orders such as close, open, FO, OFO, or other special orders such as FO, 300 ms, then FO or OF are easily configurable. All you need to know is how to fill in the 4 fields of the close and open command lines. For example, this slide shows the programming of an opening order. We start by inserting 40S in the fields of the close command. As for the opening command, fields such as 0, 100, 0, and 0 tell the CBA-32P to pick up the opening coil without delay and then hold the contactor engaged for 100 ms. To view orders in the charts, simply display them by their number, 61 for closing and 62 for opening. How do I change the current measurement scale for F&O commands using the green button 3? We have already seen that the CBA-32P control circuit incorporates a Hall effect current sensor. This current sensor can be configured by CBA-Win using the third green button. CBA-Win lets you choose from 8 current ranges, 4 DC scales 1A, 5A, 10A, 20A, and 4 AC scales 1A, 5A, 10A, 20A. If you make a current measurement of 1A when the chosen scale is 20A, you won't necessarily get the best signal. So you need to think about changing scale to get the best possible accuracy. Older circuit breakers draw a very high coil current, whereas new circuit breakers draw a very low current, often less than 1A. The CBA-32P control circuit has current protection via the control cable, which incorporates 25A fuses that are easily accessible for replacement. The CBA-32P also features internal protection against surges generated by control cabinets. These surges are cut off at 300 phi by the CBA-32P. How to modify the calculation file and tabular report using green button 6. For example, this slide shows that calculation file U141 and tabular report number 542 are used. We advise you not to change these numbers. Indeed, the planner knows exactly why he's paired 841 with 542. It is useful to remember these numbers as they are available directly from the plan. Breasts with WCF extension. For example, this slide shows that the calculation file 841 and the tabular report number 542 are used. We advise you not to change these numbers. Indeed, the planner knows exactly why he's paired 841 with 542. It is useful to remember these numbers as they are available directly in the breast plan. With the WCF extension, how do I export test results to Excel using the V6 button? Once you've saved your data as a WDT file, you can export it in Excel format. Just click on the big red X, and they will appear in an Excel spreadsheet. CBA-Win needs to know the Excel file template that will be used for this export. Excel is an extremely powerful piece of software, making it easy to create all kinds of useful reports. More and more users are using Excel to create reports. In this way, they include their logos in their reports. They take advantage of the green and red colors to issue conditional warnings of out-of-limit parameter failures. Since CBA-Win is an open software, you can extract all values already calculated in CBA-Win and integrate them exactly where your Excel template has defined them. To tell CBA-Win where to find your model, simply insert it in the box shown on this slide. For example, in this slide, first click on the last green 6 button, which is the sigma symbol for processing. In the last box identified in the Excel report file, click on the 3 small dots. Find the CBA-32 file in the CBA-Win directory in relation to Excel 3C. Click on OK, CBA-Win. You've just told CBA-Win which model to use for this test plan. Once the test has been completed, to view your results in your Excel report, simply click on the red cross to export. And you'll see the data appear in the report. The link between Excel and CBA-Win is made in this way. How to measure the dynamic resistance of arc contacts using the MOSD kit. Dynamic contact resistance measurement, known by the acronym DRM, is a widely recognized test method to check the status of main and arcing contacts without having to open the circuit breaker. The CBA-32, in conjunction with the MOSD kit, can be used to measure the resistance of any contact as a function of time. For circuit breakers, this test is carried out at rated speed or at slow speed during an opening operation. The main advantage of this test is that it allows us to determine contact wear and arc contact length, contact misalignment or mismatch, as well as other anomalies by simple resistance analysis. Contact dynamics as a function of time. The MOSD kit's current source injects a CC200 current, losing the circuit breaker when it opens. In this example, in addition to the brief appearance of the arcing contact, we can see the contact displacement curve, vibration, and the closed, then open state of the main contact. Analysis of these signals shows that the arcing contact was present for around 11 milliseconds. Correlation with displacement then enables arcing contact wear to be determined and a diagnosis to be made. For your information, the MOSD kit module is becoming more and more popular as these tests are increasingly required when new circuit breakers are installed. The aim of these new tests is to take the initial signals from the circuit breakers. During subsequent maintenance, it is then easy to compare the initial signals with the current ones. Question: how do I configure opening and closing commands? A. Using the first green button. B. Using the second blue button. C. Using the third green button. The answer is A. Using the first green button. Conclusion: this module will have achieved the following learning objectives: advanced understanding of the different options offered by CBA-32 and CBA-Win,